Physics is not everyone's cup of tea, as I remember from my first physics class after I took science stream in my 11th standard. As a teenager, I took it as a challenge and it took me time to understand physics and to relate it with daily life. And now, as I have masters in physics, I can see every day how physics is used. And at the same time, I understand there are so many students out there trying to understand it. So I bring Maxwell Equations, which are foundational for IIT JAM exams for Indian students' context, and also I think the concepts of Maxwell equation is an important if someone wants to pursue physics or well, these equations describe how electricity and magnetism work together, and they are important in physics as they can explain our daily life experience from charging our phones to the way electric devices work. So, in this video, I will explain the first equation, which states that, or which is known as Gauss law of electricity. It states that electric flux through a closed surface is equal to the charge enclosed divided by the relative permittivity of free space. And mathematically, we can represent it by these two equations. Let's go back to our statement. What is electric flux here? So, electric flux is electric charge through an area, and the other important term is permittivity. So it is the capacity of free space, how much electric field pass through a free space. Let's go back and let's understand in this way. Electric field forces are not visible forces, but they are present. So we can represent them by the arrows. So from the positive charge, electric field flow like this. In the negative charge, electric field flow like this. In simple words, electric charges create electric fields, and amount of electric field passing out of a closed surface depends on how much charge is inside it. It means more charge means more electric field lines. I hope the statement and mathematical expression is clear. Electric field through through an area is charge divided by permittivity. Well, in real life, electric fields are invisible forces, as I already told you. How Gauss law can explain when we encounter conductors like wires and Faraday cages, which are metal enclosures that block electric fields. So, engineers use Gauss law to predict how electric fields will behave around these metallic conductors. So, this helps them design electrical circuits and devices that work safely and efficiently. For example, sometimes when we enter in an elevator, our phone loses signal. It could be explained by Gauss law, how electric field inside the metal enclosure work. Also in medical imaging technology, kind of MRI and X-ray machines, though like the Gauss law is not the main body part of this kind of process, but it helps understand the electric field used in them. They work on electric fields and then interact with atoms in the body creating images. So Gauss law helped there how these fields work better, and it is an important factor for making medical imaging methods more accurate and useful. The other example in particle accelerator design. Here, electric fields push charged particles in devices and also in medical treatments like radiation therapy. Gauss law can be used to design electrodes and their shape to make particle acceleration more precise and effective. So these were some examples. Now let's move how we can use Gauss law to find the solution of these kind of problems, which are common problems in exams. Here we have given 5 charges which are situated in a surface and around a surface. Now your task is to find the electric flux. So as we know the statement, what is the statement of Gauss law? It tells about how much electric field is present through a closed surface. Present through a closed surface. So I ask students who are watching, try to solve this question. You will be able to solve this question if you truly understood this statement in the mathematical expression. So if you like this video, please subscribe, like and share. Thank you for watching.